Hello and welcome to all students. In the previous lecture, we studied about the properties of real numbers, and lastly, we saw distributive laws in the real numbers means multiplication distributes over addition. So, left distributive law and right distributive laws, these two laws we have studied. Note that using the commutativity of multiplication, right distributive law follows from the left distributive law and vice versa. Means from the left distributive law we can obtain a right distributive law by using the property of commutativity of multiplication. Now let us study about the order relation on R, the law of trichotomy. So what is that law of trichotomy? We will see here. For all AB belongs to R, exactly one of which is true. One of the following is true. Either A is equal to B, or A is less than B, or A is greater than B. So this property means that any two real numbers are always comparable. So if I take any two real numbers, then either these two real numbers are equal, or first real number is less than b, or first real number is less than second real number, or first real number is greater than second real number. So this is called as law of trichotomy, means any two real numbers are always comparable. We can make the comparison of any two real numbers always. Second order relation is, if a is less than b and there is a number c which is greater than 0, then AC is less than BC. Means if I multiply to a number which is greater than 0 to an inequality A is less than B, the inequality remains same, means AC is also less than BC. The inequality remains unchanged when both its sides are multiplied by a positive quantity. If A is less than B and there is number C which is less than 0, then, and if we multiply to this inequality A is less than B by C, then inequality will get changed and AC becomes greater than BC. Okay, so by taking some examples we can prove this thing. Suppose 3 is less than 4, and if I take minus 2 which is a number C less than 0, then multiply by that minus 2 to 2 less than 3, then it becomes minus 4 is greater than minus 6, and it is true. The inequality reversed. Third property says that if a is less than b and b is a number which is less than 0, then AC becomes greater than BC. AC becomes greater, or AC is greater than BC. The inequality reversed when both its sides are multiplied with negative quantity. So let us take any two numbers A, B, C, that A is less than B and C is a number less than 0. So you can take any examples, any particular numbers, because this property is true in general. So it is true for particular numbers also. Obviously, next thing, if A is less than B and C is equal to 0 and multiply by C to this inequality, that equality becomes equality. Inequality becomes equality, means AC is equal to BC and each will be equal to 0. Next important ordered property is the square of a real number is non-negative. This means that take any real number and make it square. The resultant is a positive. Resultant is a non-negative. Okay, resultant is non-negative. Means suppose we have a real number 2 and it's if I make a square of this 2 and that square is 4 and 4 is non-negative. For example, if I take a real number minus 2, if I take a real number minus 2 and make a square of this real number, take a real number minus 2 and its square is plus 4 and it is again a non-negative. Take a real number 0 and its square is 0 and it is also a non-negative real number. So square of any real number is always non-negative. This is important. For all a belongs to R, a square is greater or equal 0. A square is greater or equal 0. Means for all a belongs to R, a square is always non-negative. This is one of the most important property of the real numbers, which is a benchmark of the real numbers. Which is the benchmark of the real numbers. Now, next important property is denseness property. So, first of all, we see now what is that denseness property. Denseness property says that between any two real numbers or between any two distinct real numbers, there are infinitely many real numbers. Okay, this property says that in between any two real numbers, there are infinitely many real numbers. In fact, there are infinitely many rationals as well as irrationals between every two distinct real numbers. Now let us consider study about the symbols plus infinity and minus infinity. The set of real numbers has no maximal element and no minimal element. See here, the set of real number is that set is infinite set and that set has no minimal element and the set has no maximal element. Means we cannot find a minimum element of that set and we cannot find a maximum element of that set. That set is infinitely uh, numbers are increasing infinitely and numbers are decreasing infinitely. There is no minimal and no maximal element. That is for every real number a, however large, and for every real number b, however small, for every real number a greater than 0, however large, and for every real number less than b, for every real number b less than 0, however small, there exist real numbers x and y such that x is greater than a and y is less than b. Means if I take very small real number, we can find a real number which is smaller than that real number. And if I take a very big real number, then we can find a real number which is bigger than that real number. So, so there is no upper limit and there is no lower limit for the set of real number. That's why this set is called as infinite. This set is infinite set and has no upper infinite set. The set of real numbers is infinite with no upper limit and no lower limit. So consider now we know that the set of real numbers, the set of real number and the real line, these are associated with each other. Means all real numbers we can put on a line. That line is called as a real line. All real numbers we can put on a line. That line is called as real line. And every point on a real line or every point on that infinite line or every point on that real line is associated with one real number So there is one-to-one correspondence between set of real numbers and real line. Okay, so every real number we can geometrically represent on the set of on the real line. So here um, some real numbers are shown here on the real line. A 0 is at the middle. On the left hand side there is a 1, on the right hand side there is a -1, and in between 0 and 1 there are infinitely many real numbers and 1. So in this way we can put the integers on the left hand side of the 0, 0, 1, 2, 3, 4 positive integers, and we can put the negative integers on the left hand side of that 0, -1, -2, -3, and in between any two integers there are infinitely many real numbers. Okay, so in short, the real line is shown here. Okay, and see here, if we have a very big number a, we can find a number which is bigger than a, and that is x. See here also, on the left hand side of 0, if we have a very small number b, we can find what we can find a very small number or a small number which is smaller than b on that real line. So there is no upper limit for the set of real numbers and there is no lower limit for the set of real numbers. So to denote very big number, we just use a sign plus infinity. Very big means positive big number. For that we use sign plus infinity. And to represent a or to show a very small number, small real number, we use a symbol minus infinity, and we note that the plus infinity and minus infinity, they are not real numbers and they are only symbols, and they denotes plus infinity denotes only a very big real number and minus infinity denotes a very small real number. So however, it is convenient to use symbol plus infinity and minus infinity to indicate very large numbers positive and negative respectively. But it should be always remembered that plus infinity and minus infinity are only symbols and are not real numbers. Now in this way, let us stop this lecture here and we will see the remaining part in the next lecture. Thank you very much.